Hey, how are you? I'm going to be reading from Essentials of Strength Training and Conditioning. I'm going to be on page 126. This will be blood transport of gases and metabolic byproducts. Oxygen is carried in blood, either dissolved in the plasma or combined with hemoglobin. Because oxygen is not readily soluble in fluids, only about 3 milliliters of oxygen can be carried per liter of plasma. Nonetheless, this limited amount of oxygen that is transported in plasma contributes to the partial pressure of oxygen in blood and other bodily fluids, thus playing a role in the mechanisms that regulate breathing and in the diffusion of oxygen into alveolar blood and the cells of body tissues. Given the limited capacity of plasma to carry oxygen, the majority of oxygen in blood is carried by the hemoglobin. Men have about 15 to 16 grams of hemoglobin per 100 milliliters of blood, and women have about 14 grams of hemoglobin per 100 milliliters of blood. 1 gram of hemoglobin can carry 1.3 milliliters of oxygen. Thus, the oxygen carrying capacity of 100 milliliters of blood is about 20 milliliters of oxygen in men and a little less in women. The way in which carbon dioxide is removed from the system has some similarities to oxygen transport, but the vast amount of carbon dioxide is removed by a more complex process. After carbon dioxide is formed in the cell, it is transported out of the cell by diffusion and subsequently transported to the lungs. As with oxygen, only a limited quantity of carbon dioxide, about 5% of that produced during metabolism, is carried in the plasma. Similar to the situation with oxygen, the limited amount of carbon dioxide contributes to establishing the partial pressure of carbon dioxide in blood. Some carbon dioxide is also transported via hemoglobin, but this too is a limited amount. The greatest amount of carbon dioxide removal, approximately 70%, is from its combination with water and delivery to the lungs in the form of bicarbonate, HCO3. The initial step in this reversible reaction is the combination of carbon dioxide in solution with water in the red blood cells to form carbonic acid. The reaction would normally be quite slow except for the impact of the enzyme carbonic anhydrase, which significantly speeds up this process. Once carbonic acid is formed, it is broken down to hydrogen ion and bicarbonate ions. Because hemoglobin is a significant acid-base buffer, hydrogen ions combine with hemoglobin. This process helps to maintain the pH of blood. Bicarbonate ions diffuse from the red blood cells out to the plasma, while chloride ions diffuse into the blood cells to replace them. Lactic acid is another important metabolic byproduct of exercise. During low to moderate intensity exercise, sufficient oxygen is available to the working muscles. Consequently, lactic acid does not accumulate because the removal rate is greater than or equal to the production rate. If at higher work intensities aerobic metabolism is not sufficient to keep up with the formation of lactic acid, then lactic acid levels in the blood begins to rise. The aerobic exercise level at which lactic acid, converted to blood lactate at this point, begins to show an increase is termed the onset of blood lactate accumulation, or OBLA, O-B-L-A. OBLA. Alright, that's it. That'll be page 126, page 127, blood transport of gases and metabolic byproducts. Cool.